Okay, my friends, I'm going to do this in a fairly clinical way today. I need to get the world to understand that some of the things that were written in the past could very well likely have been true. And they talk about giants. Every culture on Earth, 100% talked about giant human beings, and here they are. And I'll start by showing you the DNA test. This is a left human hand. Look at it carefully. That's one of the fingertips. This is one of the fingers with the bone ball still attached to it. And on this side, it actually still has the muscle attached to the bone ball, and this is one of the tendons. Now I'm going to show you all of the anatomical shots, the x-rays, the whole thing. Now I had this CAT scanned, I had a DNA tested, and it's anatomist verified 100%. Even anybody that knows what a hand looks like can see it. There's the tendon coming down, there's a bumper pad around your hand. It's not all that hard to understand. And like I say, it's been DNA tested. And it's anatomically 100% perfect. And it's almost like somebody did an autopsy on it and said, let's open up the bone ball over here and let's look at the muscle over here. Right? And the tendon. And that's the tendon, that's the tip of the tendon that runs down. Right in this area here, right there. That's the stalk of the tendon, and that's why your fingers can do this. I'm going to show you all this in the anatomical. Let's take a look at the DNA test first. Okay, so let's start with the DNA test. This was from 2015, and it took several months to do it. This was the first one that was ever done on blood from literally rocks. They thought these were just rocks. Well, they're not rocks. They are actual body parts that petrified in a way I call mud fossilization, and I've explained this very thoroughly. And what it is there was a flood, a devastating flood on the earth, which was recorded in every culture as well. And due to the salt waters and some other conditions in certain areas, the fleshy parts of bodies were completely preserved, totally preserved, as you can see here. That's the fingertip. And these are bones and tendons and all that. And I even have a goose here, that the goose was petrified in the same manner. And there's the feathers in his head. There's a feather pattern. And as you can pick out the neck and everything if you get it in the right light and the right, if you know what to look for. I understand it. And this got flat as a pancake on this side because of the flood. And that's what happened now. Not only did I have these tested, well, I had one thing tested, the blood from one thing, but it's all from that same hand. I also had a lung tested, which is the size of us, and this came out of that same hole. And the blood came out right down this area. Boy, my shoulder's killing me. And again, flat as a pancake, because it was in the flood and laying flat. And they separated on these fascia planes. This is fascia or pleura. On a lung they call it pleura. But it's the coating of everything has to be separated from everything else. So it's basically a membrane. Skin is nothing more than a membrane. All of your intestines, your organs, your heart, your lungs, your liver, your kidneys, everything has a membrane surrounding it to encapsulate it, to keep it from other things. That's what I originally was going to call this, was fascia facilitated fossilization. I like the ring of it. But after a while I realized it was basically the mud. Being surrounded in mud is almost being still surrounded in flesh. Because mud, the red clay mud, is literally eroded flesh. That's what it is. And it surrounds all these things, and they become, there's a process called nucleophilic substitution. What that means is if there's moisture, if there's moisture, it will migrate through all these things. These are found in red clays. I have a very hard red clay area. Not hard, but it's wet and, like clay. And that's everything was stuck in this. And when it came out and all the stuff washed off, whoop, there it was. And it was almost like it was still in flesh. Now, in the CAT scan, you can see where the fingertip, fingernail is here, and you see all the blood vessels and all that stuff. But you can't see much more because it's been invaded. You see this? Here's the bone ball. Remember I showed you that's the tendon? This is the muscle. Here's the bone ball. It's gone. It's gone. Only thing you can see out here is the calcium-ish part. And inside, like this bone too, same sort of thing. This is a regular bone. And the inside will turn a different substance than the exterior calcium, like this here. You see how totally different? This just turned into mud, because that's the marrow and all the stuff inside. All right? So it's been invaded. That's what my point is this invasion here of the chemistry. But there's still, if you go into the blood supplies, you can find the red blood. It's in there. And in the lung, like this lung here, I mean, it was just saturated with blood. Down the bottom here, right now, it's all dried out after many years. But I drilled a hole right through, well, not through, but in, all you got to do is go in 1/4 of an inch or so. And you get enough little red particles out of there, they can test it very easily. You only need a tiny, tiny, tiny amount. And they did this very well. And like I say, this was the first one ever done on anything like this. I know they were doing some other, David Reich up at Harvard was doing some DNA tests on bones by this time. And I presented him with my stuff, and he said, you can't get blood out of rocks. And I said, no, I get tons of blood out of rocks. And anyway, that didn't go anywhere. So that was just the same time as this, because he was, and I went to Harvard and Yale, all of them actually. And Derek Briggs down at Yale said the same thing. No, it's impossible. And I said, well, please look at it. I got the DNA, I got the CAT scans, I got the tests, I got the specimens, and nobody was interested because it was just not accepted. Now, and now it's been 7 years. I think it's time to, somebody has to take a look at it. Now, somebody said to me, it's your pride that's getting in the way of you having anybody look at this. I said, my pride? What is it, my pride? I said, I tried to present it to all these people. Oh, no, you got to go through this certain ways. I said, I tried writing papers. I got all kinds of mentions up on academia.edu. 4,000 people mention me in different papers. Nobody will peer review me or look at anything. So I tried all that stuff. So, I don't think it's my pride that's getting in the way. But I have given up trying to approach people because I'm, somebody's, you're just waiting for them to come to you. I said, well, what am I going to do? At a point, you get so frustrated that you just have to back off and just say, well, if it happens, it happens. If it doesn't, well, good luck. But I think it's wrong for the universities not to confront this with DNA tests, CAT scans, specimens. The anatomy is flawless. And the specimens are here. They can be tested. I can be proven wrong if I'm wrong, but I can be proven right if I'm right. So it's one way or the other. And right now, not being allowed to be seen makes it so that nobody knows who's right or who's wrong. Right? So anyway, there's the DNA test, and it goes down. It was very well done, and the DNA was dense in 2 out of the 3. This was not as dense because this was more invaded. Like the lung, you can see. Here, let me just show you something. I'm going to put a little water on the tip here, and literally within a minute or so, you'll be able to see that turn pretty red. Let me just put it to the side here for a second. Let it sink in there, because it hydrates very quickly. Now, anyway, it goes down, and they successfully amplified the thing, and these were the 3 different things. Negative controls were all negative, so there was no contamination that he could determine. And these are the 3 different sequences. Now, they all had human sequences. These 2 were very dense. This is the one we're talking about here. Was not quite as dense, but it was absolutely human, no question whatsoever. He said there's no question. There was 100% human mitochondrial DNA. And 2 out of the 3 excellent quality DNA was obtained for the 36-inch tip and the lung. And these are Homo sapien and B and D loop. And certified lab, certified test, and he did a very good job, and he just wants to know, he stands behind the certification of the test, the lab director there at Helix. But the absolute certainty that I want you to understand is I was the one that did the extraction from this. If I put my own blood in there or something, well, I would be a liar. I did not do anything like that. I'm very careful. I know what I'm doing. I used all the precautions, and I extracted it from places where I knew where blood was, because I understand the anatomy. I didn't just scrub it off the edge of something and say, okay, look at that. No, I drilled into, and I'll show you in that microscope, how lush, literally, with blood these things are. And when I say lush, I mean they're saturated, some of them. All right, when they first come out of the ground, a lot of them literally had blood leaking out of them. Look at this. This is what came out. You see these little blood blobs? That came out from this lung over here. You see this lung still has all the little alveoli looking things. Well, they fill up with quartz when they empty. But this one down here, they drained the blood down this way, and it collected down here, and then it was somehow protected by mud. And when it came out of the ground, the blood came out of those little cavities. Now, you can see the alveoli. Just take your time and look at what you're looking at here. You see the holes? These little keyhole-looking things. And not every one, but most of these little blobs had blood coming out of them. Because normally these are surrounded of the airways. And there's a ton of blood. That's just what your lungs do. That's where the blood goes and passes by the oxygen, and that's what gets it for you. Now, this is the lung I have here that I showed you a minute ago. Now, that's the dense pleural. When this came out of the ground, look at this. It's just saturated with red blood. That's dry. Now, here it is now that I re-wet it. And you can see, if you really looked at that close, you would see that there's actually really good, nice red blood there. But it's been out of the ground 10 years. It's been 10 years. I've had this. Finally, well, 2015, that's 7 years ago, I decided I'm going to go full-fledged here. I'm going to pay for the DNA test. I'm going to get the CAT scans done. And the CAT scans were done by Jesse Grant and Associates, some of the best people in the world, literally. They would do CAT scans for Rolls-Royce and all of the top people in the world. They test stuff for them. And they were very, very gracious, and they did it free, because they knew what I had. And I think it didn't go all that well for anybody that was involved in this, because it wasn't accepted well, and everybody's, oh, this is bad science, you're doing things wrong. And well, I said, peer review me, test it, and nobody would. So that's the kind of opposition I've had since I started. And I know people have been down on me saying, oh, you don't know what you're doing, you got to go through this process. Well, what process is there? I did everything they asked. I expect somebody to take a look at it, but it never happened. Now, is that academically legal? I mean, if I come up with this kind of evidence, can it be just dismissed and said, no, we're not going to look at it? That's what's happened. So anyway, that's another issue. But let's just finish up so you can see. I've shown you the CAT. Well, I know I didn't show you CAT scans. Hold on. Okay, this is probably the best one of the CAT scans to show you. And now, this goes back, again, 2015, July of 2015. And this was in another channel I had before that I had to close up because they really attacked me like unbelievable. Now, you see this black area here and this white-looking area? But you see the same exact architecture. You see that? You see the little pin in the center and a pin in the center and the black around it? Well, the way your fingers work and your toes is they are terminals for your blood. It runs down with red blood, which is artery blood. And then between the arteries and the veins is all kinds of little blood vessels that lead to all the cells, because everything has to be serviced with blood. So you have red blood, And I'm not sure. I think it's probably no, but I think this is probably the vein side, and this is the artery side, because the arteries wash out because they're empty. They empty right out. The veins don't. They plug up because they have little clamps inside of them that say you cannot go backwards with the blood. You can only go up to the heart and liver and kidneys and all that stuff to get washed out. Coming down, it doesn't care. You can go this way, that way, back and forth, squish your arms and move it back and forth. But here, no, always coming back to the heart. Now, so what do we take away from this? We're looking at one, this is a tendon, and these are heavy duty. I'm going to show you the anatomical, uno momento, which is serviced with, which is the return place, the vein comes back, because it's on both sides. There's two heavy duty jobbers. I'm going to show you that as well. And this is the veins, artery side, I would say. Now, look at this. You see this bone? That should be right in the center. Now, it's sitting off to the side. Now, there's only two possibilities. I believe this is a thumb because it's so perfectly structured. And that means the bone is going to be offset. You see how my bone is offset there? You see it? I believe that's what we got here. All right, so I believe this is a thumb. Now, in the X-ray, in the CAT scans, again, you'll be able to see holes here and there, which are all the blood vessels and so forth. And then you can see where the fingertip was. But beyond that, not much, because it's pretty much totally invaded. There's still blood here and there, because the blood vessels are very, very tough. They're the toughest things in the bodies are blood vessels. Okay, this is probably the easiest way to do this. That, as you can see, is a human fingertip. And at the very end is that apical tuft, this little bumpy little part that sticks right on the top of the distal phalanges, they call it. All right, now you can see that there's two heavy-duty tendons coming down here on the sides of that fingertip, and they break right off there. And that's exactly what I showed you with my fingertip. Now, I also have more to that, which is a finger, one of the finger bones, and it's one back up in here somewhere. Where am I here? Right over here. And that comes down to a tendon, and I have the tendon somewhere over here. We go. Right there. We're going to look at what this tendon is, because it's right there is where, oops, right there. That's where my knuckle bone is from. And I'll show you that in a second, because we can see this piece running down. They have an abrupt transition. Remember, I don't know if I showed you or not, but I probably have. The bone ball is here. The wrap, some of the muscles wrap around it, and some is completely gone. One side is gone, one side has the muscles. Now, the tendons break at an abrupt transition where the fleshy part takes over. And you still have a little tiny pin inside there that is the stalk of the tendon. I hope that my hand didn't get in the way of all that stuff, but that's what it looks like. And here is what it is right here. Oh. All right, you see this? This is the same thing as that, only it's the other side of the finger. This side is eroded away, which would be this side. The other side has the same stalk coming down, and it broke right off at the abrupt transition, which is this little spot right there. You see that little, I don't know if you can see that circle there. See it? I know you can see that. Oh, my arm is not doing good, guys. Don't damage your rotator cuff. Whenever you're going to do any moving heavy stuff, just relax your arms and move them and get some fluid flowing in there. Trust me. Oh, man. Anyway, this is what you have here. Is this piece coming down and broken off right there. You should be facing this way. And there's the bone ball. And the bone ball ran back this way and is broken right off. So that's what we got there. I hope that made sense to you. Okay, so here's another shot at the CAT scan. Now, just take your time and look. These are the blood supplies coming up the fingertip. This is the best shot we're going to get of the bone, which I said was offset. Remember the bone? Look carefully. Take your time. Let me focus. Well, see, that's the fingertip right there. All right, and here it is from the bottom looking up. This is the bone, which is, remember I showed you, that's the best shot of the bone you're going to get. And this shows where the blood supplies run up. Other than that, you can't see a whole lot. Now, there's one of the fingernail tool. Hold on. All right, and don't forget, there's an awful lot eroded off of this fingertip. So it would have come up quite a bit bigger. But this is basically where the nail bed was, right in this area here somewhere. This is a pretty cool shot. This is the bottom. And right here is where that apical tuft sits. All right, that's the bottom of this fingertip. Oh. You see it? And that's where that apical tuft sits. Right there. You can actually see it, and if you get it in the right light, you can see all this stuff. You see these are straps running off it, you can see if you get it in the right light. And I could put this in a microscope in a minute. Now there's one on the top too. You see this one, that round little spot right there? I don't know if you can or not, but it's there. And that's where this one sat as well, on another fingertip, obviously. This one didn't erode. I have other ones that eroded completely, totally, as you can see on this bone. The bone one side is absolutely eroded to nothing. The other side is intact to some degree. Now, I have another fingertip here. Where do you see this one? Hold on a second. Alright, this should be pretty obvious to see. This is the pattern of a distal phalanges. And that's the tip of the finger. Now, I have it down here in the microscope, and this is what we're looking at right there, is the internal part right there of that distal phalanges. It's completely eroded. You see it's totally wet. Let me bring the light over here. Now, that came out of the same hole. This is the vein side. You see it still even has the vein tube in there. And this is the artery side. Arteries blow out. You see that hole? Completely blown out. You see that hole? Completely blown out. That hole completely blown out. That hole completely blown out. All of them. Arteries blow out. Veins plug up. See the vein? Totally plugged up. The vein totally plugged up. The tip totally plugged up. The other one's over here, totally open. That's the difference between veins and arteries. Now you should be able to see this distal phalanges pattern pretty well, I would hope. Now let's go look at it anatomically. Don't forget, there's our blood supplies. And that's what the fingertip looks like, totally eroded. It would have been a nice big round fingertip before. Alright, just to round it up, this is the pattern of the distal phalanges I showed you. That's where the black comes from. They call it bone black. Now I showed you there that that was where the abrupt transition happened, and the bone ball was under there and eroded and showed some muscle and all that. I showed that. I showed up here the distal phalanges and the apical tuft, which sits at the very end. And I showed the hand, the palm, all the way here. All of those parts from that giant. I have a screen thing going across, but I certainly hope that won't bother you. And these are all of the little components. So I see every little bit in detail. This book is absolutely fabulous for seeing details. All right, remember I showed you the fingertip in the CAT scan? Yeah, and there was a black and a white. One side was black and one side was white. Well, that's the vein and the artery. And then the two heavy-duty tendons came up the side. I showed you all that in anatomical. Then on both sides there's two holes, which was the artery blows out, and on the other side is the vein, does not blow out. And the two tips on the end, one blows out and one doesn't. And here is that tip right here. That is the bone pattern. That's where the blood comes in. One's the vein, one's the artery. The veins do not blow out. You see this? You can see where the clamp is right there and under there. And that's a hook that they make. And I can show that on the big fingertip too. That's where one of the tendons latch in. And this side is the artery side. And I remember I told you they blow right out, and they blow right out at the end. Blown out, blown out, blown out. Blown out. Clamped, 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 clamped. Just what you saw. Distal phalanges bone pattern. There's no question what it is. Now, I was going to show you something else. Hold on. Okay, now a geologist would say that's just ferrous oxide, but it's blood coming out of rocks. When they first come out of the ground, they're still literally saturated with blood, and it just leaks out because they're still moist, and that's the first scab that it shows. Now, this is when I took and moved it from the backing, which is what's called fibrin. It's a clotting fiber that blood cells cling to. And then underneath the blood, you can find the holes that fed it. And again, one of them turns black, and one of them turns red. This is the black side from the vein. This is the red side from the artery. And that's just the nature of the beast. Okay, this is a little hard to believe, but it's true. They never knew that this membranes were so complicated until just a few years ago. And now they call it an interstitium, which they used to call it a membrane. They just thought it was one little flat sheet. Well, it's not. It's loaded with these fibrous filaments and these little balls that anchor all of that stuff in, and these fluid-filled bags. Just recently announced as a new organ system, and it is, because all this stuff flows through there. But anyway, if I can show you this underneath the skin, which has eroded away, and we're down into the interstitium, which coats the flesh underneath. The flesh is the part that is not this. This is the coating. And I'm going to show you this in my mud fossils. Not only that, I'm going to show it to you in genuine leather. You have exactly the same things. All right, but the thing is, leather is tanned, so they did some stuff to it, and I'll show you that in a second. All right, now don't forget, that's the interstitium we're looking at right there. Now, I'm looking at this in my microscope, and here it is up there. Now, you should be able to see all those little black balls. I'm going to move it in and out and get a different perspective on this. All right, let's just put a little more light on it. You see the little black balls all over the place? Those are the interstitium balls. Those are the exact same balls that we're talking about in the interstitium. And above that was the layer of skin which has eroded away. All right, so this was what you can pull your skin this way and that way, and it will come back to wherever it's anchored. That is the whole idea of interstitium. Up there is some blood vessels and so forth. And this, again, this is the fingertip. Now, let me show you what the belt looks like. Remember these balls? And I should be able to show you some straps. Hold on. All right, you should see these little white things. They're the straps. The balls are underneath, but they're still there. Now, hold on. I'm drying this up a little bit. Maybe you can see it a little better. All right, it's got to sink in. Let me turn the light down low. That's biology, my friend. No question whatsoever, it's biology. And those holes and straps and balls and everything are part of the anatomical structure of skin and underneath, right underneath the skin. You can see how red-blooded it is. There's red blood everywhere in these things. It's absolutely saturated. And as soon as you put in a little moisture, all the features come out. I just put on a little moisture. And now it's getting real shiny, but you can see up over in here, you see, the balls are everywhere. All right, this is the lung. And this is the fabric of the lung, which is the same thing. It's that interstitium. It's all these straps and balls. Now, here it is in the microscope. It's exactly what we're just looking at right there. All right. Now, and that is, again, these straps and balls. Now let me show you my belt. Okay, don't forget that's the interstitium. The balls are black and hard and shiny. Now that's my belt and it's in the microscope. And here it is in the microscope. Now, as you can see, there's like these black balls all over the place. And they're broken and squished and smashed and they're very shiny. And then there's all these fibrous straps. Now I'm going to come down a little closer and you'll see, and then I'm going to put it where the belt loop is and you'll see exactly how these straps are constructed. Come on, baby. Alright, there we go, right there. Alright, you see all the straps? They run, each one of them runs to one of these balls. Hold on, let me get to where I have a good loop that I used all the time. Right there. That's a good one. Alright. So you can see now, that's how they locked in these fibers. Come right down on top of it. Alright, you see? There's the fibers and the balls. But they're smashed. And they use some chemistry. I'm not sure, I gotta look into the chemistry they use. But they smash it and then they stretch it and pull it and roll it and that's called tanning. And that's what is literally underneath the skin, just basically underneath. It's cow hide. It's the hide of the cow. You know, my father used to tan my hide. I'm not kidding you. That's what he said. I'm going to tan your hide. And he did. Yeah, now I know what he meant. Now you see this? This was the third one that I had on the test. I showed you the long and I showed you the 3 or 4 feet wide that hand was. This is almost 3 feet long. Just the fingertip itself. That's the fingernail. This little circle here, that's the bump pad. I'm going to show you x-rays of what fingertips look like. These are the blood supplies. I showed you the other ones. The blood supplies come in here. I smashed this piece off right here, and there's still fingerprints on it. And I went down inside to get the blood, because on the finger, on the grip skin, there is almost no blood. But I have some of the grip skin right in here now. I'm going to put it under a microscope. You'll see it. There is some, very, very little. Alright, I have this in here in my shop, this piece, and I'm going to look at it in the microscope and show you the blood supplies. But this is literally like a chunk. You can see this here. It came right off. It's just laying right on top of the other fingerprint when I smacked it off. And it still has the fingerprint ridges in it. And the sweat pores. This is just like rubber. That's what grip skin is. It's very, very dense and rubbery. Now, we're going to look at the blood vessels in here. I'm going to tip it upside down. We're going to look at the blood vessels in the microscope. Alright, so there it is, and here it is in the microscope. And here it is what we're looking at. Now, remember those black balls and the little straps and so forth? Well, there they are right there. That's it. Now, that's on the top of the grip skin. I almost couldn't find any blood vessels. Now, this is in a broken area in between. Now, let's see if we can find anything right in that area. Let me slurp up a little of that water. Alright, let's bring it up now. Let's try to focus it in over here. That is actually a blood vessel right there. You can just not even hardly see this. I'm going to get right up close. Then we should be able to see something. Because we'll be able to see some little pores. And wherever there's a pore, that means there's a blood vessel was there. You see the little fibers and everything in here? You see them? I should let this dry up so where you can see it, but let's see. See the little fibers? That's going to be, they're going to be all over the place here. We go right to the edge where it tips over. Hold on. Alright, we should be able to see both sides of it right here. Alright. Now, up here is where the skin is. Alright, that's where the black balls are and the straps and all that stuff was here. Now, the skin part broke off and we're down almost into the fleshy area right below. Down in there. And then I'm going to go over and over. And this is just deeper and deeper into the fleshy part of the skin. And then it'll start to get a little bloody at the edge. You see the edge right there getting a little bloody? And now we're getting towards the bottom where there will be blood. Because this is where we interface with the big part of the finger. The below part. Because all this up from there up is the tough part of your skin, the grip skin. And that's where all of those little fibers and the balls and all that, everything's there. Now below that you get into your flesh. When you cut down here you bleed. Alright, this is going to be a little shaky here, but remember that is the outside of the skin with the balls and the straps. You see them all up in there? Now I'm going to tip it over till we go to the side. That's the thickness of the grip skin. That's just the thickness of just the top skin. Now you can't really see. There's one little tiny blood vessel there, that little one right there. There's almost no blood in the skin itself. But that's the thickness of that piece of skin. You imagine that? It's a little less thick than my finger. And the fingerprints on this are as wide as my finger. One fingerprint ridge. You see all the little black balls I showed you before? And this has some of the red on it. See the little red spots there? There's some red blood here and there. Not much. Not on this grip skin. Okay, this is an x-ray, and you can see there's these little pads between the fingers and the next bone that they rock on. Alright, there's the bumper pad that I was just showing you in the x-ray, and there's the vein and artery coming in, and there's the fingernail, and that's, I think it was, I called it a 36-inch tip. I think it's maybe 30 inches, something like that. It was big, and that's the piece that I broke off, because I had to get down inside to get some blood. You can't get any blood really out of the top of any of these things. You got to get down inside, otherwise you're just scraping off the surface. Anything could be on the surface, I agree. You can't do it on the surface. Now it goes far beyond what I showed you today, but it is time to start looking at this and have someone in the academic arena do a peer review and say, well, Roger, you're wrong, or you're right, or we don't know, or whatever it is, but not to allow it to be examined. That doesn't hold any credibility for academia. I'm showing things that are easily tested, very easily tested, and this is basically a new species. The toes are built in. We call them no toes, or I do. I discovered these at the same time I discovered all the rest of the stuff. And I have a bunch of other people that have found them as well. And they even have some, Tish Egerton, a friend of mine, found that have springs inside instead of tendons. And it's a double-loaded spring. This one loads up and pulls this one in. So it like gives you a nice spring to your step. Alright, remember I told you I had the toe from that big thing too? This is it right here. Over there you can see that little, there's a tendon area there. I don't know if you can see it on this side, but one on each side. Same thing, a huge fingertip. Huge, I mean, this is a toe. And this is my hand, so you can see it's pretty good size. and now I found about 75 feet down from where the hand was. Alright, I'm going to leave it with this. This is the problem that got me in trouble, is because I am showing reality, and reality was written about in the ancient texts. Velikovsky had all of the documentations that recorded all of these events and these giant creatures, and we were almost impacted by Venus. For 7 days it approached the Earth. It was so hot and scorching that it literally boiled the oceans and the waters. It was a hot water flood. It was so impactful to the environment, to the hydrogen and the oxygen in the air, that it recombined them and turned them into water. A deluge fell. It made a cataclysm of the earth. All the volcanoes started to erupt. Geysers started spewing out of the earth. All kinds of devastation, and the result was all of these gigantic creatures died. I cannot account for what they ate and how they lived and why they were so big and how they could have possibly been here on the earth. It is apparently what it is, and it is what it is, and it is what they said it was.